Hello friends, welcome to the series of lectures of Mathematics 1. Myself Hardik Patel from LJ Institute of Engineering and Technology. Up to last session, we have seen some of the topics of multiple integral, such as multiple integral over rectangular and polar region, how to change the variable and change into the polar coordinates. Now, we are going to see the application of multiple integral. That means our application of double integration, area in a Cartesian and polar coordinate by double integration. Now first of all, we are starting with area in a Cartesian coordinate. The area capital A bounded by the curves y is equal to f1x and y is equal to f2x intersecting at a point P A comma B and Q C comma D is given by integration from x is equal to A to x is equal to C and y is equal to f1x to y is equal to f2x dy dx. Okay, that means suppose you have any two curves which are intersecting like this, and this point is P, this point is Q, and you have to find this area. Then in that case we are going to draw the strip parallel to y, and double integration dx dy or dy dx will give you the area in Cartesian coordinates. Okay, same manner, if instead of strip parallel to y, if you are going to start with a strip parallel to x, then in that case you have to find out if x is equal to g1y and x is equal to g2y are two curves, then the area is given by integration from y is equal to b to y is equal to d, x is equal to g1y to x is equal to g2y dx dy. In that case you have to draw the strip parallel to x. Points are remaining same, only you have to draw one strip parallel to x-axis like this. Now it is not necessary that your area is going to be fine for only intersection points. Suppose you have given any two curves and you are finding the area between any two lines, then also this method is applicable. Okay, same manner here you have to take the strip parallel to y. Same manner, instead of this, if you have curves like this and you have to find the area between these two lines, then you have to take the strip parallel to x-axis. Here we are taking strip parallel to y-axis. Okay, so simple formula of area is double integration dx dy over the given region capital R, and you have to put the limits of R according to yourself, according to the what are the function or conditions you have given. Okay, now area in a polar coordinates. Area in a polar coordinates is given by if r is equal to f1 theta and r is equal to f2 theta are two curves, and theta is equal to theta 1 and theta is equal to theta 2 are two lines, then the area is given by integration from theta 1 to theta 2 and integration from f1 to f2 r dr d theta. So basically double integration is given by, in a polar form, if you are finding the area, then it is given by double integration r dr d theta, where you have to put the limits of polar curve. Now suppose you have any two polar curves like this, and you have to find out the area between these two curves, in between two lines, theta is equal to theta 1 and theta 2. This is line theta is equal to theta 1, and if this line is theta is equal to theta 2, then if you are finding the curve between the area between these two, then this is the small area which we have taken, and this area is given by the formula this. Okay, now we are going with the example. Find the area bounded by the curve y is equal to x square and y is equal to x. Okay, so first of all you have to find out the intersection points of this parabola and the straight line. So you have two curves, y is equal to x square and y is equal to x. So if you have to find the intersection point, then from y is equal to x, we are going to put y is equal to x here. That will give x square is equal to x. So you will have x square minus x is equal to 0. X common out, and that will give x is equal to 0 or x is equal to 1. Correct? Now x is 0, then y is 0, because you have y is equal to x line. So x is 0, then y is equal to 0. And if x is 1, then y is also 1. So you have two intersection points, 0 0 and 1 1. Correct? So if you are going to draw the curve, then it is like this. Y is equal to x square is a parabola along positive y-axis, and y is equal to x is a line having 45 degree. Intersection point we have find out this point is 0, 0 and this point is P1, 1. Correct? Now, either you can draw the strip parallel to y or parallel to x. Here we have taken the strip parallel to y. So if we are going to draw the strip parallel to y like this, then you have a strip from A to B. Now, if you are going to write down the limits of A, then from lower curve you have y is equal to x square, and from upper curve you have y is equal to x. So if you are going to integrate, then the area is given by limits of y is from x square to x, and this strip is going to be moved from minimum 0, 0 to 1, 1, because correct, therefore the limit of x that will be from 0 to 1. So your double integration is going to be a x and y as a limit this, therefore double integration is going to be from 0 to 1 x square to x dy dx. First integration we have taken with respect to y. So integrating with respect to y, that will give y, and if you are going to substitute the limit, then you will have integration x minus x square dx. Integration of x minus x square is x square by 2 minus x cube by 3, and limit is from 0 to 1. Substitute the limit, that will give 1 by 2 minus 1 by 3, that is 1 by 6. So this is the area in between these two curves. Okay. So same manner, if we are finding the, suppose we are starting with a polar curve, find the area lying inside the cardioid r is equal to 1 plus cos theta, and outside the circle r is equal to 1. Okay. So what we have is, we are starting with a curve. So you have two polar curves. R is equal to, this curve is r is equal to 1. That is the circle. And this curve cardioid r is equal to 1 plus cos theta is the equation of cardioid, which we have already seen. Okay. So this is a cardioid. Now the conditions we have given is, if what you have given is, if you are going to draw one strip from R to curve, then in that case you have to take OAB. Correct? And your region is starting with A, ending to B. Why? See what you have given, area inside the cardioid, that means inside the cardioid, but outside the circle, that means outside the circle and inside the cardioid, that means you have this area for integration. Now, if you are going to find the intersection point, that means this point and this point, then r is equal to 1, you have r is equal to 1, and r is equal to 1 plus cos theta. Correct? So if you are going to find the intersection region, then what you will have is r is equal to 1 is equal to 1 plus cos theta, and that will give you cos theta is equal to 0. So yeah, you have theta is equal to plus or minus pi by. So this line is going to be a theta is equal to minus pi by 2, and this line is going to be a theta is equal to plus pi by 2. Okay. So if you are going to write down the regions, sorry, limits, then r is starting with the inner curve. Inner curve is a circle. That means r is starting with a 1, and it is going to end on r is equal to cardioid. That is r is equal to 1 plus cos theta. So the limits of r is from 1 to 1 plus cos theta, and the limits of theta is from minus pi by 2 to plus pi by 2. Okay. So if you are going to put all the values in double integration, then your area is going to be a double integration from minus pi by 2 to plus pi by 2, 1 to 1 plus cos theta r dr d theta. And first integration with respect to r, so it is r square by 2, limit is from 1 to 1 plus cos theta d theta. If we are going to substitute the limits, then 1 by 2 constant common out, 1 plus cos theta the whole square, that is 1 plus 2 cos theta plus cos square theta, minus 1, that will be a 1. Correct? So 1 will be cancelled out, and you will have 2 cos theta plus cos square theta. But cos square theta will be replaced with 1 plus cos 2 theta by 2. And now taking LCM, so 1 by 2 common out, and you will have 1 by 4 into the integration of cos theta is sin theta. One has an integration theta and cos to theta has an integration sin to theta by 2. Limit is from minus pi by 2 to plus pi by 2. Substituting the limits, so pi by 2, so sin pi by 2 has a value 1. So 4 into 1 plus theta is pi by 2 plus sin pi has a value 0. Minus lower limits, sin minus pi by 2 has a value minus 1. Minus theta is equal to minus pi by 2, and here if you are going to put minus pi by 2, then sin minus pi also has a value 0. So simplifying this term, you will get 4 plus 4 8 and pi by 2 plus pi by 2, that will be a pi. So this is the answer of the area outside the circle and inside the cardioid. Now we are going with one more example. Find the area enclosed by the curves r is equal to 2 and r is equal to 4. R is equal to 2 and r is equal to 4 in the first quadrant. Now again, r is equal to 2 is a circle having radius 2, center 0, 0. R is equal to 4 is a circle with a radius 4 having center 0, 0. And you have given that area in the first quadrant. So this is the area which you have to integrate, correct? Now what we are going to do, if we are going to write the limits, then you have to draw the strip from origin to the curve, transverse line, which is a transverse strip. So if we are going to put the limits, then your area is starting with the point A and it is going to be on end on a point B, correct? So if you are writing the limits, then R is starting with the circle, inner circle, that means R is equal to 2, and it is going to be end on outer circle, R is equal to 4. So your limit is R is varies from 2 to 4, and the theta is going to be varies from, since theta lies in the first quadrant, so your strip is going to be moved from theta is equal to 0 line, and it is going to move up to theta is equal to pi by 2 line. So it is, this angle is considered. Okay, so if you are going to put the integration, then your integration is of the form a is equal to integration from 0 to pi by 2, 2 to 4 r dr d theta. So this is the limit of r, this is the limit of theta, and that will give you integration from 2 to 4 r dr d theta. First integration is with respect to r, so integration is going to be r square by 2, 2 to 4 d theta, and integration, if you are going to put the limit, then 4 is a 16 by 2, that will be 8, minus 2 is a 4 divided by 2, that will be a 2. So 8 minus 2 d theta, but 8 minus 2 is a 6 and d theta is the integration theta. So if you are going to substitute the limit, then you will have the answer 3 pi. So this is the area between these two curves. Okay. So this is the simple method to evaluate the area by double integration. Correct. You have learned the area by single integration in up to 12th. Now here we have taken it by double integration. So these are the two basic formulas, a double integration dx dy or dy dx, or in a polar form it will be a double integration r dr d theta. And strip we have to put according to the given curves, either if it is Cartesian, then either parallel to x or parallel to y. And if it is in a polar form, then you have to draw this transverse line which is starting from pole. Okay. So these are the topics which we have covered in today's session. If you have any query and any doubt regarding this topic, then please feel free to contact me. Thank you so much.